Hey guys, my name is Sandeep Patel. In this video we are going to solve one more problem on the recursion, right? If you haven't watched my video on the recursion technique, please do watch because it gives you a depth explanation on how recursion works and how we can solve problems using recursion technique. Alright, so in that video I said that we can solve array problems using recursion two-step approach. Step number one is breaking the problem into subproblem, and step number two is solving that subproblem, right? Um, Alright, so let's get into this, right? So the problem is that given an array, we have to find out if array elements are palindrome, right? So what is palindrome? So palindrome means it should create a mirror image. So for example, if A be A, so if we look at from this middle element, on the left side you have A and on the right side you have A again, right? So that creates like a mirror image. If you don't have this second element, it still creates on the left it's A, on the right it's A, right? So it creates a mirror image again, right? So let's say even if you have a single element, right? There's no left and right, right? So this element itself is left and right. So this is also a valid palindrome, right? If array has no element, right, you can still call that this is a valid palindrome, right? Because there are no element you can compare left and right to, right? Okay, so in this two-step approach, we're gonna first break the problem, right? So how are we going to break this problem, right? How are we going to break this array in such a way so that it can solve this problem, right? So first of all, we need to understand how we are comparing, how we are checking whether these elements are palindrome or not, right? So you can check the first and last element, right? If they're equals, then you can say that it is a palindrome, right? Otherwise they're not. So the way we are going to do this is when we break down the problem, we are going to remove the first and last element from the array. And I'm going to tell you why we are doing this. So this time, so when we call the same function, we are going to remove the first and last element, right? And then this will call again, it's going to remove the first and last element. In that case, it becomes empty, right? So there are three calls, right? And when array is empty, we know it's already valid palindrome, right? So this is our base case. So basically we took the problem and we broke the problem in such a way so that we can solve this, right? Now I'm coming back to this part, why we took first and last element from the array, because we want to compare the first and last element, right? If we don't compare first and last element, and then we're not gonna know whether the string is palindrome or not, right? Okay, so let's check, and you'll see when I write the code. Okay, so when say array.length less than equals 1, then you can simply say return true, right? So when array is empty, we're going to return true because this is a valid palindrome. So this is our step number 2, solving base case, right? Or solving subproblem. So this is the smallest problem that we can solve, right? Okay, now the part number 2 where we had to call the same function, right? Sorry, we had to call the same function and then remove first and last element from the array, right? So you can say 1 minus 1, right? So this slice function is removing first and last element from the array, right? Okay, now we took the first and last element, but we are not using those elements, right? So we can use them here in the if condition. So we can say, okay, array's first element, if it's not double equals, array's last element, which is array.length minus 1, right? If the element doesn't match, we can return false here, right? And this is a logic to check palindrome, right? And this is our step number 1 where we break the problem. right? So we broke the problem in such a way so that we can use that logic, and then we solve the smallest problem first, right? So that's the approach. So we can run this code and you can see that when array is blank, it returns true because this is valid. When we check ABA, it's valid palindrome. And when for this array ABC, it's not a valid palindrome, it returns false. Alright, so let's look at the time and space complexity for this code, right? So in time and space complexity, what we're looking for is how many times this code runs, right, for a given execution. So when this function calls, this code runs single time, so O of 1. This runs also single time, O of 1. However, this creates a recursion, right? Because recursion meaning that it's calling itself. So we initially had array of size n, right? Let's say the array length is n, and then we shrink the problem until we got to the 0 elements, right? So you can say that this code calls itself n times, right? O of n in maximum case, right? So that is our time complexity. You can always say that, safely say that the single recursion function takes O of n only if it depends on the array, right? If you're slicing the input array, then it takes O of n. Alright, so how about the space complexity? So space complexity, we're not using any variables inside, so we're not taking any auxiliary space. However, this call stack, right, like the recursion creates a call stack, right? And this is how the call stack look like, right? In the memory you have this call stack here, so this function is calling this and this, and it it waits for this to return, right? So from here it returns to this function previously called, and then calls this, and then remove those call stack. So this call stack memory is also occupied, which is also O of n, the number of times this function called, right? So that's our space complexity as well, right? I hope you like this video. Please do like, comment, and subscribe. Thank you.